Significant figures. Significant figures are all the digits of a measurement known with certainty plus one final digit which is somewhat uncertain or is estimated. For example, if you use a ruler to measure a nail, you might find that the length of the nail was halfway between 6.3 and 6.4 centimeters. The ones and the tenths place are certain. The hundredths place is estimated and is the smallest significant figure you can find using a ruler. You write down the value as 6.35 centimeters.
All right, now, buckaroos and buckarettes, look here. What if you had this ruler right here that didn't have the tenths marks on it? Let's suppose that you had a cheap ruler. Cheap ruler. Oh, cheap ruler. Let's say you had a cheap ruler that went from 6 to 7, and let's say it was only marked at the half-inch mark. And you had a mark, you measured your nail to be right here, which is the exact same spot as this spot. How would you report that? You couldn't go past 0.3. You would have to say 6.3. You certainly couldn't say 6.5. You couldn't. Mr. Morris, you are now famous. Now, when you have these tenths marks, you're going to measure between the tenths. If you don't have them, you can't go to another digit. That's why significant digits are important. Yes? They mean something. Thank you. Now, look here, we're talking about some simple rules for determining significant figures. Focus.
Rules for finding significant zeros help you ensure that the numbers you report are accurate. Zeros appearing between non-zero digits are significant. We count these zeros when determining significant zeros. Zeros appearing in front of non-zero digits, however, are not significant. We ignore these zeros when determining the number of significant figures. Zeros appearing to the end of the number and to the right of the decimal point are significant. These zeros are only written as part of the number when they are significant. Zeros to the left of the decimal place, however, have to be written whether or not they are significant in order to designate their place. If you measure exactly 200 milligrams of a substance, then the zeros in this number are significant. If, however, the zeros are just placeholders to indicate 200 milligrams as opposed to 100 or 300 milligrams, then the zeros are not significant.
So, Ms. Davis says she doesn't get that. If we write this number as 200 with no decimal place, it says we are estimating between 100 and 300, okay? That's a 200-digit span that we're estimating. But if we put you know that those two digits are not significant, only the hundreds. Well, if you have the decimal place, then you are estimating between what? 201 and 199.
But in the last picture, it didn't have.
Well, the point is with this decimal place, 3 significant figures, then this is you are estimating in the ones bracket. Without the decimal place, you are estimating in the hundreds. Okay. All right, so now we're talking about scientific notation, and this should be a review. Okay, scientific notation.
Scientists sometimes need to express measurements using numbers that are very large or very small. Or you can express values as a number multiplied by a power of 10. This is called scientific notation. There are 8 decimal places to the right of the 3 in 300 million. So using scientific notation, the speed of light through space is written as 3 times 10 to the 8th meters per second.
Here. Let me look at this right here. Let's talk about multiplying and dividing numbers in scientific notation. 2.5 times 10 to the 3 multiplied by 2.0 times 10 to the 2 equals what? Very simple. 2.5 times 2 equals 5.0, yes? Multiply the prescripts here, and then you add the exponents. It's going to be 3 plus 2, right? So it'll be 5.0 times 10 to the 5. What is that number? 5, and then 1, 2, 3, 4, 5. Okay? Yes? Now, if you're dividing, let's say you have 5.0 times 10 to the 2 divided by 2.0 times 10 to the 4. How do you do the division? Well, you divide the prescripts. 2 into 5 is 2.5, yes, multiplied by 10, and you subtract the exponents. So this would be 2 minus 4. That would be 2.5 multiplied by 10 to the negative 2. What does that number look like? 0.025, right? 1, 2 places. That's what that means. This 5 means 5 places from here. 1, 2, 3, 4, 5. Okay? You've got to get good with that, and the way to do it, the only way I know to do it is to practice.